Continuing with section 5.2, we saw how we define the 6 trigonometric functions for a real number t using the terminal point xy on the unit circle for the real number t. So now we can, from those definitions, we can now create relations or equations between functions, between the trigonometric functions. For example, we know that sine of t is equal to y on the unit circle and cosine of t is equal to x. And we define the secant of t as 1 over y. But y is sine of t, so we can have this relation. We see that this is true, that cosecant is 1 over y by definition, but y is sine of t, so cosecant of t can be written as 1 over sine of t. In the same way, sine of t is actually can be written as 1 over cosecant t. Why? Because what is 1 over cosecant? What is cosecant t? It is 1 over y. So here this thing is 1 divided by 1 over y, which when simplified gives us y. And sine of t is y, so this is true. And in the same way, you can look up for the rest of these. Now, these equations are often called identities. What is an identity? Identity is an equation that is true for every value in the domain of the variable. So here is the definition of an identity. So it is an equation, but it is true for every value, every allowable value of the variable. And now it says to compute values of the trigonometric functions for any real number t, we first determine their signs. The signs of the trigonometric functions depend on the quadrant in which the terminal point of t lies. And this is the following chart, which will help you remember. And you can remember it like what has been given here, or you can just remember where the terminal point is. If it is in the second quadrant, the x coordinate will be negative, y will be positive. So when you are using that x value, you can figure out which of the trig functions will be negative and which will be positive. So you can either remember with these trig functions, or you can use the just the coordinate signs of in each quadrant. Okay. Now so here is the heading fundamental identities. Some basic or fundamental identities we will write here or mention, and then we later on in later chapters we will develop or we will find out new identities using these old identities, using these fundamental or basic identities. So, but before I get into the identities, I want to explain a special notation that will be used for the trig functions for each one. So, like all the 6 trig functions. So, let's say we have these trig functions, which I am calling the basic trig function, and now you can raise them to any power, positive n. So, any power which such that n is a positive number. So then, but how do we write that? Because that is very important. Notation is very important here. So it says when you have sine of t whole square, okay, sine of t whole square. Now we cannot write it like this. We cannot say sine of t squared, because that looks like the square is on t, not on sine t. And if you are putting the parentheses around, well, that leads you to this what we have in the start. So here we actually have another notation which we use, and that is to put the 2 on the sign, not on the t. So we write it like this, sine, and we read it sine square t. So when you see sine square t, it means it is sine. So we write it like this, sine square t, but the square means that it is the sine of t value that is going to be squared. And in the same way, all the rest of the functions like cosine square t, secant square t. So secant square t is basically secant of t whole squared. And notice here n has to be a number which is greater than 0. So n has to be a positive number. And if we have, if we have n is 3, we can say sine cube t. And what about if n is 4? Now we don't have like a word, nice word for it. And what about n is 10? What about n is 100? And so we can't have like for each one of them a word, because it will become hard to remember all those. So now we in general we say that if the power is n, so we sine to the n of t. We don't say sine n t, because sine n t will be something we'll see later, n t. So n is when the t is multiplied by some number that will be can be read, or that can be read as sine n of nt, or sine nt, or sine of nt. So when it's a power, you should say sine to the nt. But what it means, it doesn't mean that sine square into t. It does not mean that, because sine itself has no meaning. Sine square itself has no meaning unless you have it on the number t. So this is a special notation that you have to kind of get used to. So now we look at the identities, as we said, the fundamental identities. So the identities that we just saw in the beginning of this video, those are all our we call them reciprocal identities, and these are basically one of the fundamental identities, because these are the ones with which we are starting our kind of trigonometry. And then we have something called Pythagorean identities. And the Pythagorean identities, the first one is definitely from the equation of the unit circle. X squared plus y squared is equal to 1. Remember, that is the equation of the unit circle. But what is x? How did we define x? X is defined as the function sine of t. So sine x squared, so we will have sine of t whole square, which as using our special notation, we write sine square t plus cosine square t, which is equal to 1. Well, according to this equation, it should have been more like cosine square t plus sine square t is equal to 1, which is actually doesn't matter, because these are positive numbers, sine square t and cosine square t, so we can switch anyway. Now, these other two identities are actually can be derived from this first identity. So you can work in terms of the cosine and sine, or you can work in terms of the x and the y. So if I use this one, sine square t plus cosine square t is equal to 1, and now I can divide by cosine square t so each term will be divided by cosine squared. The first here gives me what? So this can be, because it's sine square t over cosine square t. So I can write it as sine of t over cosine of t whole squared. But what is sine of t over cosine of t? That is tangent of t. So I get tangent of t whole square, which is the same as tangent square t. Plus, now the next term is 1 equals. Now this can be written as, you can think of that as 1 over cosine of t whole squared. So which is 1 over cosine is secant. So secant of t whole square or secant square t. So you get the second Pythagorean identity. And now if instead of cosine square t, we divide by sine square t in this step, then we will get this third identity. Also note from this identity that the cosine square t plus sine square t is equal to 1. It has some other forms as well. So you can have cosine square t equals 1 minus sine square t. You can write it like that. Or we can have sine square t is equal to 1 minus cosine square t. I hope you guys understand how to get these. So these are other forms of the same identity. In the same way, you can have other forms for the other two Pythagorean identities. Okay, let's move on to our examples. So here the question says find the exact value of the trigonometric function at the given real number. So what is the real number in the first? By the way, exact value, because remember you are not allowed to use calculators, so you have to find the exact value. However, so here t is 5 pi over 6. I hope everyone can see that. So how do we figure out? So it's always a good idea to draw like a unit circle, small unit circle, and then place this value over at that where it should be. It's a 5 pi over 6. So if you recall, how many pi over 6s do we have in the upper half of the unit circle? We have 6 pi over 6. Pi over 6. So first one, so from here, if I divide this piece into 3 pieces and this into 3 pieces, so then 1, 2, 3, 4, 5, 6. So you see we have 6 pieces. So this will be the 5 pi over 6. 5 pi over 6 will be here. This line denotes the 5 pi over 6. So what will be the terminal point for that? Well, it will have the same x and y coordinates as we have for pi over 6. So for pi over 6, what coordinates we have? If anyone can remember. So remember, these are the coordinates that you have to remember or memorize. So all these t values which have in the first quadrant, all the terminal points you should know. So here we get square root of 3 over 2 comma 1/2. Those are the coordinates of pi over 6. What are those? Square root of 3 over x, 3 over 2 comma 1/2. And when you try to write the coordinates of 5 pi over 6, they will be the same as values will be the same as for pi over 6, but the difference is that the x coordinate will have a negative sign because we are in the second quadrant. So that now sine 5 pi over 6. Well, how do you find it? Well, sine was defined to be the y coordinate. So it means the sine of 5 pi over 6 is 1/2. as the y value over here. The next, so let's say cosine of 7 pi over 3. Okay, pi over 3s. How many pi over 3s do we have? Well, in the first quadrant, we have, in the upper half of the circle, we have 3 pi over 3s, and then we have 4 pi over 3 will be somewhere here in the third quadrant, and then the 5 pi over 3 will be here, and the 6 pi over 3 will be here, which comes out to be 2 pi. Okay, so we are talking about 7. So we have 6 pi over 3 up till here, so 7 pi over 3, because we already completed the whole circle, so we are going to go forward. So this is one more pi over 3. We are at 7 pi over 3, so this is the 7 pi over 3. Now, if you notice, this is landing on pi over 3, where the pi over 3 would be. So its terminal point has the same coordinates as pi over 3. So we have 1/2, comma, square root of 3 over 2. So cosine of 7 pi over 3 will be equal to the x coordinate, so which is 1/2. Okay, next we are looking at tangent of 2 pi over 6. Well, you can simplify it a little bit, because 2 pi over 6 is pi over 3. And if you leave it as what you have, still you will get the same answer. But let's do it. So this is the same thing as tangent of pi over 3. And we already know from the part 2 here that what is the coordinate terminal points related to pi over 3. So that tangent will be, remember, it's the y over x. So this value will be square root of 3 over 2 divided by 1/2. Now simplify, so square root of 3 over 2 multiplied by 2 over 1. So the 2 and the 2 cancel out, so we are left with square root of 3. The next one, cosecant of negative 11 pi over 6. Now, you learned earlier that when we are counting the t values, or when we are counting these real numbers moving on the unit circle in the counterclockwise direction, we have positive values for the real number. So the positive values go in the counterclockwise direction. If we move in the clockwise direction, we will have negative t values. So the pi over 6, pi over 6. So how many pi over 6s we have in the whole circle? We have 12 pi over 6. Yeah, but now we are moving in the counterclockwise direction. Sorry, the clockwise direction. So we are going like this. 3 parts, 3 parts, 3 parts. Yeah, it will be moving like this: 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and then 8 pi over 6, and 9 pi over 6, and 10 pi over 6, and 11 pi over 6. So we arrive at 11 pi over 6, which is actually same as pi over 6. So what is the coordinate for that one? Square root of 3 over 2, comma 1/2. So what will be the cosecant? Remember, the cosecant is the 1 over the y. So it will be 1 over 1/2, which will be 2. So this is how you should be able to evaluate these values. The next is saying cotangent of negative pi over 4. So pi over 4. So we are moving in the negative direction. So pi over 4 is over here. So what is the terminal point related to that? Well, remember it will be the same as what we have for pi over 4, but the only difference is that now the y coordinate will be negative over here in this case. So x coordinate and then negative y coordinate. And what are the value, or what is the coordinate? Well, you have this will be have square root of 2 over 2 comma square root of 2 over 2. So here we will have square root of 2 over 2 comma negative square root of 2 over 2. So cotangent is x over y. So we get square root of 2 over 2 divided by negative square root of 2 over 2, which gives me negative 1. So cotangent of negative pi over 4 is equal to negative 1. Next is secant of 7 pi over 4. So we have how many pi over 4s in the whole circle? So we divide each quadrant into half, starting with from in the positive direction. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 pi over 4s in here, but we have to land at the 7 pi over 4, which means we are landing here. So this is the t all the way from here to here. That is what our t is, and the coordinates will be the same as the coordinates of pi over 4, because this is a multiple of pi over 4. So, but the only thing will be that the coordinates are. So note here that negative pi over 4 and 7 pi over 4 are actually the same things. So we have the same coordinates as we have in part 5. So secant is 1 over, secant of t is 1 over x. So the x coordinate is positive. So this will be 1 over square root of 2 over 2, which is the same thing as 2 over square root of 2. Now usually we don't leave the denominator as with the square root sign. So let's rationalize. What do? I multiply top and bottom by square root of 2, which is equal to, so now I get 2 times square root of 2 over square root of 2 times square root of 2, which is 2. Now 2 and 2 can get cancelled and we are left with square root of. So this is how you can evaluate the function for the given t. Okay, let's do the next examples in the next video.